Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 69. Square root of x. Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use the inbuilt functions. Okay, they are asking us to find what? Floor of square root of x. Okay, so just see here. By explaining this example, it will be more clear. If I take 4, what is square root of 4? It is 2. Floor of 2, it is again 2. Okay, that's why the output is 2. Now, take this 8. What is square root of 8? It is 2.8 something. Okay, now again taking this as floor. Okay, taking this as floor, what is my value? My value will be 2. That's what the problem statement tells us. Okay, now how can we approach this problem? Okay, the main case is we want to find a square, right? Just imagine in a reverse way. In a reverse way, if I want to get this 4, I want to make what? 2 into 2. If I want to get this 8, it is floor value, right? It is floor value. Then I maybe take 2 into 2 or 3 into 3. Maybe in that range, right? So just see here, by using this example, it will be more clear. My approach is just I take a 0 to 8. Okay, now see here, 0 square is 0, whether 0 is less than 8, yes, whether this 1 is less than 8, yes, whether this 4 is less than 8, yes, whether this 9 is less than 8, no, it is not less than 8, it is greater than 8. So what should be my answer? My answer should be what? 2, right? So this is what the basic approach. Now what is the time complexity for this basic approach, and what is space complexity for this basic approach? So I can say the time complexity for this approach is square root of x, and then what is space complexity? It is O of 1. Simple. Okay, so this is all about the brute force approach. Now let's just step into the optimal approach. Just see here, if I rearrange this in terms of array, just for a visualization, then this is my array, see here, this array is in what? Is in sorted order. This is the important note. Why? Because this is a sorted order array, right? Why can't we use the binary search approach? Okay, so we are going to use minus search approach. Just take this as my lower pointer and this as my upper pointer. Okay, now what is my mid value? I can say my mid value is this 4, because 0 plus 8 it's 8, 8 divided by 2 is 4. So this is my mid value. Now tell me whether mid value is greater than 8 or less than 8. It is greater than 8, right? So mid value is greater than the x. In that case, what should I do? Should I move towards right side or towards left side? Okay, for this question, just imagine if I move towards right side, whether there is any value that matches 8. No way, because every value is greater than 8, right? But we want a lesser value or equal to 8. So we want to move where? We want to move towards left side. To move towards left side, what should I do? I should do u is equal to mid minus 1, so that u will be placed here, because here is mid, right? Now you will be placed here. Just take out it. Now again, what is the mid value now? I can say the mid value is here. Yes, yes. Now think about it, whether the mid value is less than 8 or greater than 8 or equal to 8. It is less than 8. So what's the second condition? It is less than the target value. Okay. Now in this situation, this one may part of my answer. Yes, maybe my part of my answer. So I will take this one as my part of my answer. Okay, I will take this one as my part of my answer. Okay, but still we can get a better answer when we go towards right side, because we have 4, we have 9 remaining. Yes, this may be matched with 8. If there is 8, any 8, it will be matched, right? So that we want to move towards what? Towards right side. As of now, it is my answer. This is my best answer. Now to move towards right side, L is equal to maybe plus 1. Just move here. Strike out this and strike out this. Yes. Now this is my mid pointer. This is my mid pointer. Now 4. Whether 4 is less than 8. Yes, it is less than 8. Then update an answer. Yes. Now my answer is what? Now my answer is 2. This in this, right? This 2. Now again, we want to make this L to point here. Mid plus 1. Mid plus 1. Okay. Now again mid is here. Now 9 is greater than 8. Okay. 9 is greater than 8. So u is equal to mid minus 1. So take this u and shift here. Shift here. So u is here. L is here. U is less than L. So condition terminated. So stop here. So what is my output? It is 2. Okay, okay, it is fine. We have found out two conditions. What are the conditions? If it is greater than x and then mid value is less than x. But the main condition is mid value. If, take for example, mid value is equal to x, then what should I do? I should return. I should return that in this. But why should I return that in this? Just imagine. Just imagine. If 2 into 2 is 4. If 4 is found, can I get a better answer? No. That's why I am returning that in this. Right? Now, how to do this problem in a coding format? Okay, just observe carefully. This is way easier than you think. Just see here. This is my low pointer. This is my low pointer and this is my high pointer. First of all, assign them. Low pointer is equal to 0 and high pointer is equal to what? 64. First of all, assign this. Sorry, instead of the 64, assign what? Assign as 8. Initially as 8. Okay, this in this. Now, while finding this midpoint, after that, instead of this mid value, just apply mid into mid, because this 8 can be written as 8 into 8, which is equal to 64. That's why we are using what? Mid value as mid into mid. Now understand? Okay. Now combining all this, we are going to write a code now. Just observe. This code is super simple. Here L comma u is equal to 0 comma x. Now result is equal to 0, while L is less than or equal to u, mid is equal to u plus L divided by 2. We can also write as L plus u minus L divided by 2 in C++ Java, because we will face a integer overflow error. Okay. Now if mid into mid is equal to x, then I want to return what? Mid. If mid into mid is less than x, what should I do? I should update in my answer, right? I should update in my answer. Then I want to make sure whether there is any better answer in that array. So I want to move towards what? Right side. So I am moving towards right side. Else, else means what? It is when mid into mid is greater than x. If it is greater than x, then I should do what? I should come towards left side. So yes. Okay. Now let me submit this code. Okay. What is the time constraint and space constraint for this code? So here it is submitted successfully. Now we are going to analyze the what is the space constraint and time constraint. Just observe carefully. What is space constraint? I can say, sorry, what is the time constraint? I can say that time constraint is O of log n base 2. Okay. And what is the space constraint? It is O of 1, because this is constant space, right? Now we are going to compare whether log n base 2 or O of square root of n is efficient. Which one is efficient? Okay, let's take the input size is 1000. The input size is 1000. Now, what is the answer for this log n? I can say this answer is 100. Sorry, what's the answer for the square root? The square root is 100, right? What's the answer for this log n base 2? It may be like I think so 13 point something, right? 13 point something. So see here, it runs up to what? 100 times, but it runs only up to what? 13 point something. Maybe if we round off to C, then it will be 14. So 14 is more efficient than this 100. That's why we will use this as my optimal approach. Okay, my message. Fine. It is more clear now. That's all about this question. Thank you.